Hi Year 11, today what we're looking at is logarithms. Our learning goals are to define logarithms as indices and recognise and use the inverse relationship between logarithms and exponentials. So let's have a little bit of an investigation to start off with. Logarithms are a way of looking differently at exponentials or indices, where an exponential function is going at a rate for a particular time to get a final result. Now, if we look at our first exponential here, 2 to the power of 5 equals 32. What we have with this exponential is we have our 2 is our base with our exponential. Now, we also have called these similar base, calling it a base when we talk about indices. We have our power is 5. And then what we have is we have our answer is 32. So what we technically have when we're looking at this exponential is we have our base to the power of p, equals a. Now, when we do this and we change an exponential to a logarithm, we use log BAP. So what that means is we'll have log with our base of 2 to our answer of 32 equals our power of 5. And so what that looks like is log BAP. Okay, so we have log to our base, answer equals power. And so these are interchangeable. So we already know that 2 to the power of 5 equals 32. And how we write this exponential as a logarithm is log base 2 of 32 equals 5. How we say the logarithm in words is we say log, I wanted to do that in black. We say log of base 2 of 32 equals 5. Okay, let's have a look at our next one. So we have 2 to the power of 0 equals 1. Here we have our base is our 2, our power is our 0, and our answer is 1. So this is in the form of b to the power of p equals a. So we want to write this as a logarithm as log BAP, log base b, answer equals p, or a equals p. So when we substitute these in, we'll have log with our base of 2, our answer of 1 equals 0. How we say this is we say log of base 2 of 1 equals 0. And we can see this connection and use log BAP to help us to change exponentials to logarithms and also to identify how to get logarithms back to exponentials. So for this last one here, we want to identify our base, our power, and our answer. And then we want to substitute that into our log BAP. So this means we'll have log of our base is still 2, our answer is a half, equals our power of -1. Okay, we can say this as log of base 2 of a half equals -1. I'll just fix up that e. Okay, so that's how we change an exponential to a logarithm. And what we can do is we can connect this to a growth rate. So we can say that our 2 in each of these cases, our b is like a growth rate. The power is the time that the thing is growing for, and then our answer is our result. So if you know how fast you are growing, and this is how big you end up, you're working out how long you are doing it for. Okay, to change our logarithms to an exponential, sometimes we don't always have our answer, but we still want to use our log BAP, and this is how we remember how to change exponentials to logarithms and logarithms to exponentials, is using our log BAP acronym, I suppose, and easily identifying that we have our base, power, and answer. So with our logarithm, we have our base is our 3, we have our answer here, and then we're going to work out what this logarithm equals. So we have our B and our A, and we still want to work out what our power is. So for our exponential, if we change this into our B to the power of A equals P, we have our base of 3 to the power of what? Oops, I've just written this wrong, haven't I? To our power of what is equal to 81. So what we want to say to ourselves is 3 to the power of what equals 81. Now we can just have a little muck around on our calculator by going 3 squared, 3 to the power of 3, 3 to the power of 4, and we'll find that 3 to the power of 4 equals 81. So because 3 to the power of 4 equals 81, this means that log base 3 of 81 equals 4. So we can use this interchange of our exponentials and our logarithms in order to get the answer to what logarithms equal. So for log base 5 of 25, like I said, we have our base, we have our answer, and we want to work out what our power of our exponential is here. So we use our B to the power of P equals A. So we know our base is 5. We want to work out what our power is, and this equals 25. So we all know that 5 to the power of 2 equals 25. So that means that log base 5 of 25 equals 2. And our last one here is log base root 3 of 27 equals what? So our base here is root 3, our answer is 27, and we are trying to work out what the power is. So what we can do is use our log BAP and use our B to the power of P equals A, or our base to our power equals our answer. And so when we do this, we'll have our B of root 3 equals 27. Now, what we have to do is we have to work out root 3 to the power of what equals 27. Now, when we're thinking about root 3, what we have is that root 3 times root 3 is equal to root 3 squared, which equals 3. And we know that 3 to the power of 3 equals 27. So this means that root 3 to the power of 6 is going to equal 27. We can even check this on our calculator by going root 3 to the power of what equals 27. And when you get to 6, you get the correct answer. So what you were thinking is, what power must I raise the base to so the answer is the number in the log? The logarithm of a positive number y is the power to which a base a must be raised in order to produce the number y. So for example, log base 2 of 8 equals 3. And this is because 2 to the power of 3 is equal to 8. So if y equals a to the power of x, then x is the logarithm of y to the base a. Just as at the exponential function, y equals a to the x is defined for all positive bases only, a is greater than 0. Logarithms are also defined for a is greater than 0. Also, a cannot equal 1 because 1 to the power of x equals 1 for all values of x. Logarithms are related to exponential functions, and they allow us to solve equations like 2 to the power of x equals 5. So for a logarithm, if y equals a to the x, then x equals log base a y. Now let's have a look at some examples doing this. So with our first example, what we have here is we want to write log base 4x equals 3 in index form and solve for x. So we want to look at our log BAP, and you are going to get so used to this by practicing our logarithms here. So if we want to write log base 4 of x equals 3 in index form and solve, we know that our 4 is our b for base, our x is our answer, and our 3 is our power. So we have b, a, p. So we can then use this to write this into index form. So we'll have our b of 4 to our power of 3 equals x. Okay, so therefore x equals 4 cubed, and x equals 4 cubed is equal to 64. Now we want to write, for example, 5 squared equals 25 in logarithmic form. So we have our 5 is our base, we have our power of 2, and we have our answer of 25. And so we want to write this in log BAP form. So this means it'll be log b, which is 5, answer of 25 equals 2. So we are replacing our b, a, and p as so. Okay, for our next one, what we have is to solve log base x of 36 equals 2. So again, we want to identify our b, a, p. So I have my b is x, my a is 36, and my p is 2. And I want to change this into index form. So my base is x, my power is 2 equals 36. Now I just want to solve what x squared equals 36. So that is equal to x equals plus or minus the square root of 36. Now what we must note is that x is the base of the logarithm, and for logarithms our base has to be positive. Has to be greater than 0, as our base cannot be negative. So that means that we disregard the minus sign. So we just have x equals root 36. So we get x equals 6. We don't need that root 36 there. Perfect. Okay, our next one here is we want to evaluate log base 3 of 81. So what we're going to do is we know that we have this in the form of log BAP. So we could let log base 3 of 81 equal x, we could let it equal y, we could let it equal so many things, but because we're using log BAP, let's let log base 3 of 81 equal p. If we just use our p, we're going to get into the habit of that p equals our power. So we have our base, we have our power, and we have our answer for our BAP. And so what we have is we'll have that our base is 3, our power is p, equals 81. And now what we want to do is we want to think 3 to the power of what equals 81. So we're going to go 3 to the power equals 3 to the power of what equals 81, and it equals 4. Now, because our bases on both sides of the equal sign equal 3, what we have is we have our answer at the top, being both our powers, equals 4. So that means that therefore we have our answer to be that the answer of log base 3, so therefore we have log base 3 of 81 equals P. Now there is another way that we can do this. Our other method to do this is we have log base 3 of 81. Actually, I'm not going to show you the other method just yet. We're going to do something else and then I'll come back to it. Sorry. Okay, our last example here is to find the value of log base 2 of a quarter. Again, we're going to look at log BAP. So we know that we have our, and we're going to let our log of 2 a quarter equal P. So we have our B, A, P, our BAP. So we have B, A, and our P. So that means we're going to have 2 to the power of P equals a quarter. Now we'll have 2 to the power of P equals 2 to the power of what equals equivalent to a quarter. So when we're thinking about this, a quarter can be written as, or it equals even, 1 over 2 squared. And we know our index laws. We know that when we have 1 over a to the power of m, it equals a to the power of negative m. So that means our 2 to the power of p is equal to 2 to the power of negative 2, which is equivalent to a quarter. So therefore we have p equals negative 2, and therefore we have log base 2 of a quarter equals negative 2. Oops, I want to get rid of those dots. Sorry. Okay. Now that we've gone through that, we're going to have a little look at some properties of logarithms. So we can notice that logarithms and exponentials are inverse operations. This means that they're the opposite of one another. So what we have here is we have these properties. We have, if we have log base a of a, it equals 1. Now this is because a to the power of 1 equals a. Now if we use our log BAP on that, it works out because we have our a is our b, we have our 1 is our power equals a. Now our next one is log base a of 1 equals 0. So if I look at my base, it is a, my power is 0, that equals 1, because anything to the power of 0 equals 1. Now, if I have my next one, I'll have log base a of a to the power of x equals x. So if I look at my base, a to the power, my power is x, it equals a to the x. And the last one here is a to the power of log base a of x equals x. And that is because if I change this into log form, I'll have log of my base a of x equals log base a of x. Now on our reference sheet, we have these properties really hidden as this. On our reference sheet, we have log base a of x. Log base a of a to the x is equal to x is equal to a to the power of log base a of x, which is on our reference sheet. So we have these two, 1 and 2, on our reference sheet, but just because they both equal x, it is written in this form. Okay, so we are going to have a look at some examples now using these properties. Our first example is to simplify log base 8 of 1 equals x. So, or equals what? We're trying to find out what it equals. So we can let it equal x, we can let it equal p for power, whatever we want. I'm going to go with p for power because that's what we've been doing. We know we have our b, we know we have our a. So what this is equal to is, let's do an actual equal sign. So what we have is this equals 8 to the power of p equals 1. Now we know that 8 to the power of 0 equals 1. So therefore we'll have log base 8 of 1 equals 0. So we can work that out that way. Now if we have log base 8 of 8, we're going to let that equal p. What this then equals is we'll have our base and we have our answer. So we'll have our base of 8 to our power equals our answer of 8. This is where we'll have 8 to the power of 1 equals 8. So therefore, we write this in log form. We'll have log base 8 of 8 equals 1. Our next one, we'll have log base 8 of 8 cubed. We're going to let it equal p. So we'll have our base of 8 to our power of p, equals our answer of 8 cubed. And so that means that our p equals 3 because we have that our bases of 8 are the same. So we want to find out what these are equal to. Let's actually do them in green because we're talking about our power. And so therefore this means that log base 8 of 8 cubed equals 3. What we also have when we're looking at log base 8 of 8 to the power of 3 is we have that log base 8 of 8 to the power of 3. What we do here is we bring this power that we have here down the front so that we have that it's equal to 3 log base 8 of 8. Now, log base 8 of 8, we have already worked that out in this question here. Log base 8 of 8, we have calculated that to be 1. So whenever we have log of base 8 of 8 or log base anything of itself, that just is replaced with a 1. So we're left with 3 times 1, which just equals 3. So we can also work that out that way. Okay, this last one here, if we have 3 to the power of log base 3 of 7, what we can do here is we have, that hasn't loaded, is we have 3 to the power of log base 3 of 7. So we are using this law up here. We're using this one here. We're going to use the fact that a to the power of log base a of x equals x. And this is where we have that a equals 3 in both cases and x equals 7. So we can therefore just go straight to 3 to the power of log base 3 of 7 is equal to 7. Okay, moving on. Now, we have different types of logarithms. We have common logarithms and natural logarithms that you can find on your calculator. So if you look on your calculator, our log buttons are above cos and tan, and we have our common logarithm, which has a base of 10. So on our calculator, we just see that as log x, okay, or log, it's really log of base 10 of x. When we see a question with base 10, we can just press the log button. We then have the natural logarithm, and with our natural logarithm, it has a base of e. So that means we see log base e of x, or we use ln of x as short, and we just press our ln button for that. So the natural logarithm of y equals log base e of x is the inverse of the exponential function x equals e to the power of y. Now, something that we have is we have that we have that log of 3 does not equal ln of 3. If you press log of 3 on your calculator, what you get is 0.47712, etc., which does not equal ln of 3 on your calculator, which is 1.098612, etc. So it's really important that if the question uses log, L-O-G, we use the log button. If the uses log to the base e, or it uses ln, what we do is we press our ln button. So this means that log base 10 of 3 is also not equal to log base e of 3, okay? The reason for this is if we let log base e of 3 equal x, what we get is it converts to our base is e, our power is x equals 3, or if we let log base 10 of 3 equal x, we'll get our base of 10 to our power of x equals 3, and these are just not the same thing. So on our calculator, we're going to find log base 10 of 5.3 correct to 1 decimal place. So you are simply going to press on your calculator log 5.3. When you press log 5.3, you get this to equal log base 10 of 5.3 equals 0.724275896, which equals 0.7 to 1 decimal place. Now, to evaluate ln 80, what we have for ln 80 is on our calculator, you are just going to press the ln button and then 80. And when we do so, what we get is that that equals 4.382026,635. Now we've been asked to 3 significant figures, so 3 significant figures is our first 3 non-zero digits, so it equals 4.38. Finally, we can use logarithms in real life scenarios, such as when measuring loudness in decibels, looking at the pH of a solution, and in formulas to model other different situations. So our first example, or our only example here, before we get on to some exercise work, is loudness in decibels is given by the formula L equals 10 log base 10, I over I0, where I to the base 0, is the threshold sound, or sound that can barely be heard. Sound louder than 85 decibels can cause hearing damage. So the loudness of a vacuum cleaner is 10 million times the threshold level, or 10 million I base 0. How many decibels is this? So what we want to do here is we want to use our formula of L equals 10 log base 10 of I over I base 0. This is where we are going to let our I equal 10 million, I base 0, okay, because that is our threshold, because I is our top there, when I base 0 is just our threshold sound, okay? So when we sub this in, we get L equals 10 log base 10 of 10 million I base 0 over I base 0. Now what happens here is our I base 0s cancel out. So we just get that L equals 10 log base 10 of 10 million. Now, if you just press log of 10 million into your calculator, it will straight away tell you. So if you put this into your calculator, actually we're using orange to signify that we're putting something into our calculator. So if you put that into your calculator, you get that that is equal to 7. So that means our loudness is equal to 70. Now, if you didn't know to put this into your calculator, we can have a little look at it over here. So that's all that we put onto our calculator. Now, if we looked at our log BAP, what we would get is we would have a look at, we have log base 10 of 10 million. And what we are trying to do is we're trying to find out what this power equals, what this P equals. So if we then change this from a log to an exponential, we will have 10 to the power of what equals 10 million. So we then have to have a little play around, but we know that when we have 10 to the power of the power is how many zeros we have. So when we're looking at 10 million, we have seven zeros. That means that 10p is equal to 10 to the power of 7. So that means we have that p equals 7 for our this. And so therefore, we get that log base 10 of 10 million is equal to 7, and that's why we replace our log base 10 of 10 million with 7, or because we're in log base 10, our calculator will do it for us. Okay, our next part of this example is if the loudness of the sound of rustling leaves is 10 decibels, find its loudness in terms of I0. So we have our formula, L equals 10 log base 10 of I over I0. And this is where we let our L, because our loudness is our decibels, or our sound of our leaves even, equals 20, sorry. So we will have 20 equals 10 log base 10 of I over I0. Now we want to get rid of that 10 out the front, so we're just dealing with a log. So what we do is we divide both sides by 10. So 20 divided by 10 is 2 equals log base 10 of I over I0. Now we want to use our log BAP here and convert it to an exponential. So we have our base is 10. We have our power is going to be 2. And we have our answer is our I over I0. So what this is 10 to the power of 2 equals I over I base 0. Now we want to find out the loudness in terms of I0. So what we want to do is we're trying to find I, so we multiply both sides by I0. So what we get is we get that I equals 10 squared times I0. We can just expand to that 10 squared is 100 I0. That is the end of the theory. What you need to do now is exercise 804, question 1, every second letter, question 2, question 3 to 8, every second letter, and question 9 to 16.